So welcome to another subtopic in Fundamentals of Pharmaceutical Calculation. Very important concepts for you to cover to move on to advanced topics which are part of the syllabus for pharmaceutical calculations. In this video, we're going to focus on number 4 and 5 on this page, rounding off and paying attention to figures that are significant. Standard form notation or exponential notation will be in a video all by itself. That way we do not have to rush the learning and cram everything into one video. Let's go. Rounding off. Rounding off is essential in PharmCal because of the device, the measuring device that you have. So I have deliberately placed a 50 ml measuring cylinder here, and if you look at the measuring cylinder, the note in the text box says logic plays a role. Let's look. 50 ml measuring cylinder and the subdivisions. For the purpose of PharmCal, the questions normally tell you the subdivision. And this will come out when you move across to Unit 10, which is called Metrology. So this part will come at you again in another topic for the syllabus. So you can measure 21 mil, you can measure 22 mil, but you cannot measure 21.2 mil if the measuring cylinder says that the subdivision, the little lines in between, is only in increments of 1 milliliters. So therefore, if you want to measure this volume with this 50 ml measuring cylinder, you would therefore measure 21 ml and not 21.2 ml. If you needed 22.6 ml in the measuring cylinder, using the principle of rounding off, the 6 is greater than 5, so this would be equivalent to 23 ml. And so what you're saying is, I am willing to accept the error of my rounding off, and my error in my rounding off should be within the 5% limit that pharmacy practice allows. And so whenever you're rounding off anything at all, you should always have in mind, did I exceed the error that pharmacy practice allows? Another thing too, you do not want to just round off and not be aware of your error, right? Because that can be real negligence when you're dealing with medication that are dosed as micrograms. Remember, 1,000 micrograms make 1 milligram. So when you round off micrograms, the impact can be so significant for a potent medication as opposed to a drug which is not so potent, right? So let's go. Rule number 1. If the digit to be dropped is greater than 5, at least retain the digit and increase by 1. For example, we want to drop the digit 6 in this scenario, 12.6. So we would round off to 13. Okay? It means I'm adding 0.4 mil more liquid than I intended to. Now, using the principle of percentage, you can find out the percentage of that 0.4 mil. And because we're doing percentage in Unit 1, I will use the liberty of putting it here in this video for you. Now, let's see what this is. So I'm inserting a shape. Right? I'm inserting a shape here just to calculate the error for you so you can appreciate what we're talking about. So 12.13 minus 12.6 would leave me with 0.4. 0.4 mil is what I have added. So when you put 0.4 mil over the total of what you really wanted, which is 12.6 mil, that's what you wanted, right? Times 100, because we're converting it to percent, right? By now, everybody should know percent means out of 100. 0.4 mil divided by 12.6 times 100 is 3.17% error. This will come again when we are doing metrology in Unit 10. Now, are we within the error pharmacy allow? Yes. Pharmacy allows for a 5% error. If we had exceeded the 5% error, even if it mathematically the rounding off looks okay, but if the error is going to compromise the patient's safety, then we would get a device that measures the 12.6 and measure for accuracy. So think again, you can either round off or change the device to one that will allow the 12.6 to be measured accurately. Now, what is the next rule? If the digit to be dropped is less than 5, then we will keep the main digit that is to the left of the decimal or to the left of the number. So let's go 12.4, and we will keep it to 12 because the 0.4 is less than 0.5, so we're literally dropping it. Again, in pharmacy practice, this is a big thing. That means that you're dropping off some of the medication. And so how much of the medication are we dropping off? You need to be able to check your error. All right, so we are measuring 0.4 mil less than what was intended. So let's check our error. 0.4 mil was removed, right? We really needed 12.4 mil in this scenario. So it's 0.4 mil what we're dropping over what we should have measured, which is 12.4 mil, times 100.4, calculating real time while doing this recording. That would be 3.2% error. Are we within the error limit? Yes, we are. Can we move on? Yes. If we were at risk of exceeding the error limit, then we would get a device that can measure the 12.4 for accuracy. If the digit to be dropped is 5, okay, so we're at the middle of the road. It's neither above 5 nor below. We're at 5. What does math says? If any digit following it is not 0, then the last remaining digit is increased by 1. So the digit following the 5 should not be 0. That's what we're going to focus on. So in this case, it is 12.51. And so we round up. There we go. We increase by 1. That's what the math theory says. So we will measure actually 13. This means that we're adding 0.5, almost 0.5 mil more medicine than intended. So again, you have to think, do I need to make this error, or can I just get a device that can measure what I want? Just for you to know. If the digit to be dropped is 5 and it is followed by zeros, then the remaining digit is increased by 1 if it is odd but left even. Students, I will not stress you with this, but these are things that mathematically you have to appreciate the principle. So let's look at this. If it's 11.5, they're saying nothing follow, no 0, no number follows nothing, so you round this to 12. If it's 12.5 but no number followed, you can round it also to 12. You can drop it or you can increase it. So when it's middle of the road, we're really not that critical in marking you right or wrong in the context of the lab. The only thing I will say is calculate your error and see the impact, and if needs be, you go and get a device that measures with accuracy. And those are the things you learn when you move on to us in year 2 in doing your pharmaceutics lab, for which PharmCal is a prerequisite. When rounding a measurement, retain as many figures as will give you only one uncertain figure. Let me go again. When rounding off a measurement, retain as many figures as will give you only one uncertain figure. So in statistics and in life, there's always one uncertain figure. And so in this context, what we're saying is, if you are measuring 11.3, right, and your answer you're getting is 11.32, the 2 is the uncertain figure in that. Okay, and so you can drop. You do not have to feel anxious. You can drop off numbers. Just round off responsibly. When eliminating superfluous figures, yes, some numbers can be long. Think of those recurring decimals and all those digits, right? You don't need it, so you can round off. So they're saying that 2.43 can be rounded off to 2.4 because 3 is an uncertain digit. Okay, 2.46, the 6 is greater than 5, so we will round this number to 2.5 because we're going to round up when you're going to be dropping a figure. When adding or subtracting, we're at number 7. When adding or subtracting approximate numbers, include as many decimal places as are in the number with the fewest decimal. Let's look at this. So we have a math where we are adding 162.4 grams. So this is one place of decimal. We are also adding 0.489 gram. That's 3 places of decimal. We're also adding 0.1875 gram. That's 4 places of decimal. And we're adding 120.78. That's 2 places of decimal. Right here is where the decimal places are. And so without highlighting it, person should be aware. Now, there's something in pharmacy practice wherein we try to avoid decimals and many zeros because that increases your error rate. So this is why now the metric system have grams, milligrams, and micrograms. And so in the previous lesson, when we interacted in class, I did say to you that you could have converted all of these figures into milligrams by multiplying by 1,000, and so you eliminate many of the decimal. However, in PharmCal, the questions will normally tell you, give your answer in grams, or give your answer in milligrams, or give your answer in micrograms, because at that time, we will be assessing your ability to convert within the metric system. That's not the objective of this question. The objective of this question on this page in front of you right now is that we're trying to see if you understand the principles of decimal and when to round off. So the one with the fewest decimal would be this one. That is the one with the fewest decimal. And so here we will add everything together. When we add it together, we get 283.8565, but we need one place of decimal to match the 162.4. And so that one we will round to 283.9 because right here we have a 5 and the digits after are greater than 0. So we're not going to just drop it. Okay? Now, let me go to a new page so that we can flow very easy with the document. So as you read through, you're going to play this recording so you can hear my voice. Let me see how far we are. And we're finished. We're almost finished. Let me see if I can get it in the 15 minutes. 1 minute to go. Right? When multiplying or dividing two approximate number, retain no more significant figures. So hence our next recording will deal with significant figures than the numbers having the fewest significant figures. Similarly to the places of decimal above. Okay, so here we have 1, 2, 3, 4, 5 digits. We're going to multiply by 0.26. And these are the numbers that we get for your answer. But we will round it to 0.43 because 0.26 have the fewest number or places of decimal. So our answer would not be this long number, no. Our answer would match the one with the smaller number of decimals or significant figures. So to conclude this recording, keeping it to 15 minutes, rounding off is important in pharmacy practice. Thank you.